Hi, it's Jan Beta, and many moons ago I made a video about repairing this NAD3020 old school vintage amplifier from the 70s, I believe. And the video ended with me telling you about the broken insulators below the power amplifier transistors. So yeah, I managed to put modern silicon insulators in there, and then I completely messed up because I forgot to check for short circuits and things like that. And I managed to short all the power transistors to the ground. So when I turned this on without double checking, it just blew up and didn't give me any sound output, basically. So yeah, I was really disheartened, and I actually procrastinated looking at this for several years now because it was such a massive oopsie on my part. And yeah, basically I was really stumped. And now I promised this amplifier, which is a really decent, lovely sounding amplifier, to a friend of mine, and I want to give it to him. And yeah, I have to look at it again now. So join me on this new adventure, if you will. So here's where we are with this. I did several things in the meantime after the last video. I put the original power transistors, because they were all fine, back in there, put silicon insulators below there, which are also heat conductive, so you don't need any additional thermal paste. And well, yeah, at first I managed to short the legs of these transistors to the heatsink, which is, yeah, basically it connected all the transistors in the wrong places, and I turned it on for a while. These little resistors blew up. They were basically turning into coal, and the whole power amp section was basically shorted. I already replaced these resistors, which are just 180 ohms standard resistors. And I think there are several blown up transistors in the power amp section, especially these here. We're going to check most of the transistors in this video and hopefully fix the whole amplifier in the process. Another thing that I did off camera was to replace this fuse holder here on this little daughter board, because that was loose. One of these, this one had very loose contact, so I just put a proper fuse holder in there. Not a big deal, but I just wanted to point that out. And here's the schematics for the power amp section. I already marked the parts that I suspect to maybe be broken. These are the big CAN transistors, the 2N2955 and 2N3055, which are the NPN and PNP pairs that have the actual amplification, the power amplification. Then our preamp section. The first stage of the power amplification are these 2N6554 and 2N6551 transistors, and I believe these are completely blown up. The power transistors probably are fine, they can take quite some heat, but the smaller components on here might all be wonky. So I'm going to take a look at those at first. So yeah, basically these transistors here I'm going to desolder one by one and test and see what they are. But first of all, you can pretty quickly determine if the transistors are completely blown up, if they are just dead shorted on all the pins. So we're going to test that. I have my multimeter set up in continuity testing mode, so you're going to hear little beeps if there's shorts. Yeah, and as you can see, these are the transistors. The first stage of the power transistors that I was talking about, and they are all more or less dead short on all the pins across everything in all directions. So I strongly believe at least these are toast. The main power transistors are good, actually. They are not that short, which is good. And the smaller components that are before the power amp circuitry appear to be fine, at least they are not that short, so I'm going to focus on the ones I pointed out at first, which are incidentally, of course, because that always happens, because Murphy's Law, basically, they are the components that are the least easy to get, I think. They are not very common anymore. You can find replacements for those, and I was able to source some from France, actually, which are, I think they should be compatible. They are the next higher voltage rated ones in the series. I hope they work fine in this context. Otherwise, they are pretty much the same specifications. We're going to get into that in more detail in a bit. I'm just going to desolder these one by one and test them. So fortunately, these are pretty easy to reach, so I'm just going to desolder them one by one. This is a single-sided board, so we shouldn't run into any issues. Should be easy to work on. Yeah, so this the first one I desoldered. It's a 6554 type. These were made by Motorola originally. You can still find replacements for these from some other manufacturers, but they are not so easy to find because they are basically obsolete these days. But yeah, as I said, you can find several replacements that work. They are not very special in any respect, but yeah, you have to watch the data sheets and match them with something that works. And as I said, I just ordered some of higher voltage rated ones that hopefully are going to work. But first of all, let's test this. So I'm using this cheap component tester that I bought ages ago specifically for testing transistors, because I don't have any other means of testing them. These are really handy for stuff like that. And as you can see, my transistor here shows up as 2 resistors, which, yeah, basically there's dead shorts on all pins. So that's dead. Severely and utterly dead. So we found one faulty component already. We're going to see about the other ones. Yeah, it seems these are all just completely and utterly and deadly shorted from all the pins. So yeah, all the pins are shorted together, so yeah, they are pretty much melted inside. Okay, let's see if anything else on the board is shorted now that I've removed those. No, these are not shorted. So probably we just blew up those transistors, fortunately. Or rather unfortunately, but at least it's just those. The power transistors are actually fine. That's good. And for the replacements, I ordered some from France. Can recommend this seller. That was really quick. Found them on eBay. So these are 2N6556, which are actually higher powered versions of the 6554. And 6553, I got some original ones. These are even Motorola chips. They have the same funky color code on the back there. So yeah, these are the ones I'm going to put in there in the correct orientation as replacements. And these were not easy to find, as I said. It's really difficult to source these. They are out of stock for most new parts suppliers, so I found some new old stock ones, as I said, from France. Kind of lucky there. And it should work fine. They have basically the same specs as the original ones, but they are suitable for higher voltage supplies, but they should work fine for lower voltage supplies also. So yeah, I'm going to try that. Cross your fingers that this is going to work. And yeah, let's put them in and see what we get, basically. These are used in complementary pairs. The 6554, which are lower voltage versions of the 6556, are the NPN transistors, and the 6553 are the PNP transistors that are used in pairs here. And there's actually markings on the board, which direction they go. Not very clearly visible, but you can still see it. And I took pictures of the initial configuration. So I'm just going to solder these in first and then go with the 6556s. Ah, that's much better. They are not shorted. So, supposedly, this could work again. Let's try. Yeah, in order to test this without massive risk of blowing up things again, I made this little contraption. And yeah, I've never done anything with this. This is a so-called dim bulb tester, which basically consists of a mains lead and an incandescent light bulb that is put in series with this mains outlet. And the purpose of this is to limit the current going to the device, and also the light bulb is going to light up according to how much current draw there is. So if this stays very bright after you turn on the device, there's going to be a lot of current dissipated in the bulb. And that's actually good because it protects the device, but it also tells me that there's kind of a short in the device somewhere, something wrong. Usually it goes bright for a bit and then it dims down slightly if the device we're testing is working correctly and there's no shorts. These are actually pretty commonly used by like hi-fi repair people all over the world. Kind of an old school way of current limiting, but it's a very easy to achieve way. And yeah, I kind of wonder why I didn't think of this earlier. I've probably blown up some amps because I didn't have current limiting in place. I have an isolation transformer that you can set the voltage to different levels, which is actually pretty handy for these repairs. You can slowly ramp up the voltage if you're testing a device, but that doesn't limit the current, and the current is what actually kills the components. So this is going to be pretty useful. You need different bulbs for different applications, different wattages. I went with the 60 watt bulb mainly because that's the one I had at hand. This is a very old school incandescent bulb. You can't do this with modern LED bulbs because, yeah, basically they work in a completely different way and have their own internal power supply and things like that. These just have a wire that glows, and that is also the resistor in this case. So, yeah, we're basically putting a resistor in series with our outlet here. And hopefully that's going to protect our device in case something is still wrong there. And we're also going to have an indication if there's something severely wrong. So yeah, let's try that. First time for me. I hope this works. I'm also going to put links in the video description about more details about these dim bulb testers. Pretty interesting stuff, pretty basic, but pretty effective. And as you know, that's the kind of device I like. Simple but effective. Kind of like my credo for this channel. Just going to turn on the power and see if it blows up. Yeah. And we had this bulb go bright, as you've probably seen, for very briefly. And then it turned very low. I don't even know if it lights up at all, because we don't have anything connected. I think the filament in this is not going to go very bright with this amp in any case. So yeah, I think this is a promising result so far. I just want to hook up some speakers, I think, and see. Yeah, and it seems like we didn't blow up any more transistors so far. That's good. I think we're good. And before I hook the speakers up, I'm going to check for DC voltage on the speaker terminals there. Okay, that's very low. That's a tiny bit higher, but it's 0.07 volts. So we don't risk our speakers here, I think. I have pretty high hopes at this point. But I'm still running it through the dim bulb tester, as you can see, because you never know. Let's see if it lights up now a bit more. Oh, I have to plug it in. Let's see if it lights up a bit more now that we actually have a load. We actually do have quite some hum now. Okay, let's see if we actually get something. I have just hooked up my phone here as a sound source. And as you can see, our dim bulb tester is still in place. Lights up. Yes! That's Focus 10 you're hearing there, who provides his music for free for my channel, which I'm really grateful for because it's amazing. It does work! Yeah, fortunately it was just those 4 transistors that were severely and utterly blown to bits. Otherwise it seems to work fine. I'm now going to test it without the dim bulb tester in place. So we still have a bit of hum going on there. That was probably caused by the case not being on and things like that, and some of the appliances in my little lab here are causing interference with the signals. But other than that, at least it works again. That's pretty nifty. And yeah, I'm pretty happy because I put so much work in this previously and replaced all the electrolytic capacitors and things like that. So yeah, this makes me severely happy at this point that at least we got it outputting sound again and nothing blows up so far. Yeah, with the dim bulb tester in place, we are going to get supply voltages that are slightly off, but still this means this works. And I'm now going to plug the mains plug directly into my mains outlet without the dim bulb tester, because I don't think we risk blowing up anything at this point anymore, which is good. Yeah, I plugged this into the regular mains outlet now, and the hum is completely gone. I think we just had some under voltage there somewhere. And now it sounds better as well. These are sweet sounding little amplifiers. I know that there's a lot of discussion going on about these, and they are not the best made amplifiers, but they have a certain sweetness to them that is just, it's just kind of baffling for what it is. It's a relatively low powered amplifier, and yeah, it drives these speakers very well. I also tested it on large floor standing speakers in my living room, and it sounds amazing, and it just has no problems handling those like 4 ohms, 100 watts I think speakers in my living room, which is kind of amazing for an amplifier this size and quality. But yeah, it is kind of a legendary amplifier, especially these early models of these, so it would have been kind of a bummer if I wouldn't have fixed this. So yeah, I'm pretty relieved that I got this to work again after all these years. I'm not sure, I'm not even sure when I started working on this, but it was just sitting idly in the corner here basically for all this time, and now it lives. So I tested this for a bit, for a couple of hours, and listened to some nice music, and it works flawlessly, which is amazing. Pretty relieved it was such an easy fix in the end. The transistors were not easy to get, as I have pointed out, but otherwise it was pretty straightforward to just measure them and determine they were completely shorted So it wasn't a massively exhausting troubleshooting process. There's a little step back that I just encountered when I wanted to set the bias and things like that. Let me show you. Yeah, so here's the problem. I wanted to measure the DC offset, the bias of the amplifier, and for that I wanted to connect some multimeter probes to these speaker terminals, which are just very cheap plastic spring-loaded things. And look what happened. We have a nice crumbled piece of plastic, and this one also has some damage. So yeah, I think these are rather standard parts that you can find basically everywhere in every electronics store and on eBay and such. And I ordered a replacement for this already because that probably makes sense in the long run, because I don't think this is easily fixable. These are, yeah, it's a combination of a little metal part that actually holds the speaker cables, clamps them in, and a plastic part that holds the metal part. So yeah, that completely crumbled when I wanted to test this. And yeah, it's going to be a couple of days until the part arrives, and in the meantime I'm going to try to glue this back. I have some nice model making plastic special glue here that I want to try to use. Usually this is really sturdy because it just basically forms a weld bond on the plastic parts, because it dissolves plastics, and then you can basically make a part that is as sturdy as before. I think the plastics in this case are brittle because they are more than 40 years old now, and yeah, plastic tends to get brittle over the years, especially if it has some heat going on or some UV light and things like that. We're not going to be able to permanently fix this, but for this video I think I want to try to glue this back together just to be able to finish this. Okay, I have more or less successfully puzzled these together. So yeah, I hope the glue is strong enough, but usually it is. I put a whole joystick back together with this glue and it still holds up. So let's see if we can get them back into the terminals. Okay, there are these spring-loaded wires here that we have to get in here somehow. Yeah, I have no idea if this is going to work. No, it's already moving. Okay, let's try if the other one works at least. Yay! Okay, one is back and it feels sturdy at least. Yeah, I'm afraid that's going to be it for this video. I'm still waiting for some parts and they are going to arrive in a couple of days, and hopefully I'm going to make a follow-up video to this one soon. The electronics should be pretty much fixed now, so next time we're going to be looking at fixing the speaker terminals and also setting this up correctly. Like, the idling current is a pretty uncommon procedure, to put it mildly, and it's not very clear from the service manual. In fact, there are several bugs, so to say, in the service manual, and if you follow that procedure you're not going to get anywhere. We have to cut some traces and things like that, and add some specific resistor values to specific solder points on the board, but we're going to do that in the next video. And hopefully we're going to be able to fix this fully. So yeah, that's it for today. Hope you still enjoyed it, even we didn't do much. It was an easy fix, thankfully. And yeah, just to say that these things happen. Don't be too disheartened by blowing up stuff. It happens to all of us, and you have a bad day sometimes. You don't think twice about things, you don't measure correctly. Things just happen. Don't be disheartened. try to fix stuff, it feels even more satisfying if you fix it again after breaking it yourself, I guess. So yeah, thanks for watching. Special thanks to everybody who supports me on Patreon and on the channel memberships page on YouTube. I hope to see you again on this channel. This is not the primary focus of this channel, the vintage audio gear I'm working on from time to time. It's kind of a hobby of mine from dating back even before the other stuff I usually do on this channel, the retro computer and retro consoles stuff and repairs. I love these old hi-fi devices and just I'm going to continue working on these from time to time and going to publish videos on this channel from time to time about them. Hope you don't mind. Maybe you even find this more interesting than the retro computer stuff. I know there's not a lot of videos going in depth into these NAD3020 amplifiers in particular, so I thought I'd post these videos. There's going to be at least one more about this device. Hope to see you again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye.